So, it is your call if you pay attention to me or if you do the Chapter 9 review, which will be on page 673, and we will be doing numbers 4 through 32 evens. That is going to be due tomorrow, because tomorrow is your test. Okay? So, yes, sir.
When do we turn our math books?
When any time after tomorrow.
Oh,
Okay? Because tomorrow you need them, or you need them at least tonight to do your homework. Okay? So yeah, so textbooks can be turned in starting tomorrow at any point in time. Okay? All right. So, what do we need to know about things that we had in this chapter? Okay? Well, we started out with the distance formula and the midpoint formula. The distance formula was that. The midpoint formula was that. Okay? So we got to know how to utilize those. Okay? Then we went on to parabolas. We had two forms of a parabola.
You can use a card on the test, right?
But you only get one.
oh, what does the P mean?
P is the distance from the center, or excuse me, from the vertex, because it's a parabola, from the vertex to the focus, and from the vertex to the directrix. Yeah. We'll get to it in a minute. Okay? From that, we learned that we have the vertex is at the point H comma K, and we base everything off of the vertex. Okay? So, as Kellen was just asking, this 4P business, the 4P is what we use to find the distance from the vertex to the directrix or the focus. Okay. So we use that. And so then things that we would need to find would still be, we would have to find the focus. We would have to find the directrix. When we were doing it, we also found the width. Of the parabola.
How do you figure that?
The width, 4p.
I never read it.
width of the parabola through the focus. 4P is the width of the parabola through the focus.
Is it split it in half?
Yep.
And you just answered it, so from one side of the parabola to the other would be all of 4P.
All of 4P
Okay, so
through the focus.
So it'd be okay, you've got the focus in the middle, and then you've got the side of the parabola. Would that be 4P, or would that be half of 4P?
Half of, so
Okay.
2P.
Okay.
Okay? Questions on parabolas? We might also have an opening in there too, an opening type question. I don't think there's anything else that we had there in terms of our basic stuff. We go back and look at an old quiz. Oh, axis of symmetry too. Can't forget axis of symmetry. Good with parabolas. Okay. Then we went on to circles. In that circle, we had a center. And we had a radius. Pretty straightforward with that. Any questions circle-wise?
How do you figure out the radius?
Take the square root of r squared. Okay. Then we went to ellipses. What did we have with an ellipse? We had a vertex. Nope. Well, we had center first. Let's go in normal order. So we had a center first. And everything goes off of the center then, right? Okay. We had vertices, right? We had foci. Nope, that's hyperbolus. We had a major axis. We had a minor axis.
Do both the foci and vertices are found on the major one, right?
Say loud.
The foci and the vertices are both found on the major one.
Both found on the major axes. Yep. Okay. What else are the vertices? So instead of saying on the major axes, we could say something else there. In an ellipse. That's the major axes. Look back in your notes. What else can we say about vertices? Or what else can we say about foci?
Well, both sides a squared equals b squared plus c squared, right?
How do I tell what's A and what's B?
Bigger,
Matt?
bigger numbers A.
The bigger number is A squared? Yep.
Yep.
And by numbers, we're talking denominators, right? Yeah. What else can we say about vertices? It's the endpoints of the major axes, right? So instead of saying on the major axes, let's say that they are the endpoints of the major axes. Major axis is the longer one. Minor axis is the shorter one. Anything else? Okay. Then we went to hyperbola. Oops, there were two of them. Oops. What do we have? Got a center. What else? We got asymptotes. Foci. What else? Vertices.
What are the vertices on it?
They're the sides of the midpoint of the sides of the box. Yep. Depending upon the direction of opening.
Random question.
Random answer. 92.
Regarding ellipses, what is it co-vertices, just like
Yes, the other two endpoints, but I won't ask you that.
Because it just says whole whole vertex in the book, and I didn't know what that was.
Yep. Depending upon which way it opens. So if it's an up-down one, it'd be the midpoints of the top and the bottom of the box. If it's a left and a right one, it'd be the midpoints of the right side and left side of the box. Okay. What else? How do we find the foci? Okay. And in this one, we should probably put this on the ellipses too. C is the distance center to foci, right? What else?
Asymptote is diagonals and box,
It's the diagonals of the box.
and equals plus or minus b.
Okay. So the slope of the asymptotes is going to be plus or minus b over a, and this is going to be the diagonals of the box, which means that they go through the center, correct? So if we don't have the y-intercepts, we can use the center in the point slope form to find what they are. Yep.
If there, because that equation is y equals mx plus b, is there gonna be a plus b? And how do we know what it is?
How do you find the b in the y equals
Yeah.
mx plus b? You got to look at your box, okay? And if a side of your box is on the y-axis, then it's an easy find, okay? Or option 2, your center is on the y-axis, okay? Or option 3 is you got to use the point slope form, which is y minus y sub 1 equals m times x minus x sub 1, where you use the center point to do that with a positive slope and then with a negative slope. It's two different calculations.
What was point slope form again? Just y minus y1 equals the slope times x minus x1.
In the x minus x1 is in parentheses.
Oh,
Yeah.
yeah.
Okay. Then we went on to 9.6, where 9.6 was putting them into standard form. Okay. So on here then, you would need to use completing the square techniques. Okay. Two reminders about completing the square. First reminder is always stay balanced. Meaning if you add 16 to the left side, make sure that you're adding 16 to the right side. Okay? Stay in balance with your equations. Okay? So definitely want to do that. Okay? The other thing that people struggled with, and they are still struggling with, as evident by the quiz that I just corrected too, is in a hyperbola case, and only in the hyperbola case, okay, you're factoring out. So if it was like, for instance, minus y squared plus 6y, okay, when you go to set that up, that becomes minus, and then a set of parentheses, y squared minus 6y. You've got to make that change because you've got to factor out that negative sign because it's a hyperbola. Okay? So your b changes. It's happened 2 straight weeks now, and nobody's picked up on that. And I've said it a couple of times. You've got to factor out that negative sign in the hyperbola. Okay? So that when you would actually fill this one in with plus 9 there, but really you're subtracting 9 from that side. So you'd have to subtract 9 from the other side to stay balanced. Okay? That's been a source of lots of missed points the last 2 weeks. Okay? Any questions on putting them into standard form or recognizing what's what? Remember that if there's only one squared term, it's a parabola. If there's 2 squared terms and you're subtracting the squared terms, it's a hyperbola. If there's 2 squared terms and you're adding them and the coefficients are the same, it's a circle. If the coefficients are different, it's an ellipse. Okay. Then the last section that we did was the section that we did last week, which was quadratic systems. Okay. There are 3 ways to solve a quadratic system. There's substitution. Except I would only use substitution if you have a line or a parabola. Okay? I would not use substitution if you were to have a circle and a hyperbola, or a circle and an ellipse. Okay? Basically, if you have 2 squared terms, substitution is out. Okay? If you only have 1 squared term in one of your equations, okay, you can use substitution. But if you have 2 squared terms in both of your equations, forget about substitution. Okay? That leaves elimination. And I would solve using elimination in that case when you've got 2 squared terms. Okay? There, you could also graph them, but I will tell you this, that on tomorrow's quiz, okay, both of them are solvable. Both of them can be done with substitution. Actually, I lied. One of them can be done with substitution, and one of them can be done with elimination.
So there's only 2.
There's only 2 tomorrow.
Okay.
We only have an hour. Okay? So again, that homework that is due tomorrow is there.